All right, so let's go ahead and do this. So to use normal CDF, we go second, and then distributions here, so you hit bars, and then, number 2, norm CDF, so you scroll down here, enter, and then your lower value. So for the case that I'm showing right now is the probability that a randomly selected student scored more than 65, okay, with a mean of 63 and a standard deviation of 5, okay. So we have, since it's more than, the lower bound is 65, and the upper bound will be 10 to the 99. So I just put 10 to the power of, and then hit 99. Okay, just to be extra safe, I'm going to put it in parentheses. Okay, so then that, and then the mean is 63, and your standard deviation is 5. Okay, so then we hit paste, enter, and there it is. You have lower bound, upper bound, mean, standard deviation. Now in the case of the standard normal distribution, your mean is always going to be 0 and your standard deviation 1, okay? But right now we're just doing, plain old normal distribution. So there it is. So that's, this actually is going to be 0.34457 or 0.3446. So what this represents is area underneath the curve of the normal distribution, where the mean is 63 and you're going from 65 to the right end of the tail, okay? So if you look at a picture, it's going from left to right. Your lower will be on the left and your upper bound will be on the right. Okay, so this case is where we're finding the probability for x less than 65 with a mean of 63 and a standard deviation of 5. Okay, so starting fresh. Okay, so we're going to do second distribution. Okay, and then we're going to go to normal CDF. Okay, and then we hit enter. And then our lower bound in this case, because the graph, it's the left side of 65 all the way down to the tail. So we're actually going to have a negative 10 to the power of 99. This way we ensure that it gets the tail all the way to the left, okay? And then the upper bound, it's going to find all that from the very left of the graph all the way. It's going to keep going until, and then we're telling it here, stop. Your upper bound, or the value that you need to stop at is 65. Okay. All right, and then 63 is our mean, and standard deviation is 5, so we're good there. Then you just hit paste, and boom, there it is. One thing I also want to say is notice that this here is the complement of what we found before. The last example, it was 0.3446. If we add these together, you'll get 1, which makes sense because the total area underneath the curve is 1, right? This would be all the area to the left of 65, and then previously we did all the area to the right of 65. And remember that if you just found the area of a single, for a continuous distribution, area of a single value is 0. So when you add these two together, you get 1. Okay, so here we're finding the 90th percentile of scores given a mean of 63 and a standard deviation of 5. Okay, so basically we're doing the reverse. We're saying, okay, I want to find this value k such that the area underneath the curve up to k is 90%. Okay, so what we do is we need to use an inverse function. So, so we go again, second, distribution, and then you scroll down to inverse norm because it's a normal function, right? Normal distribution. So the area is basically 90%, right? And then we have here our mean is 63. Our standard deviation is 5. And then we're using the left tail, so we leave that as it is. And then you hit enter. And there you go. And your 90th percentile is 69.4. In other words, the probability of getting the area underneath the curve all the way up to 69.4 is 90% of the entire curve. Okay? Very good. Okay, guys, so this is the case where you're trying to find the area between two values. Okay, so remember the probability, we're trying to find the probability that x occurs from 1.8 to 2.75. So it's pretty simple. You just, like how we do, second distribution, go down to normal CDF, yeah? Enter. So now my lower bound is going to be 1.8 in this case. And my upper bound is going to be 2.75. And then my mu, or my mean in this situation, is 2. And my standard deviation is 0.5. So doop-de-doo, that's how we do it. You hit enter and paste, and that's it. So the area under between 1.8 and 2.75 is 0.5886, or you can say about 59% is in there. in this example, we're finding the max number of hours per day the bottom quartile of household uses a personal computer for entertainment. In other words, we're finding the 25th percentile. Let's go ahead and do that. We're going to use inverse norm. So second, distribution, you go down to inverse norm. Remember, it gives us that k such that the probability of x less than k is 0.25, right? So the area is 0.25. The mean in this example is 2. The standard deviation is 0.5. Okay, and we're using the left tail. And then you hit enter. And that's it. So we would say here the maximum number of hours per day the bottom quartile of households use a personal computer is 1.66 hours. Okay, so here we're finding the 80th percentile where the area to the left of the curve all the way up to a certain value k is 80% of the entire data, okay, of the entire, it's 80%. Okay, so let's go ahead and do that. So you would use second distribution, go down to inverse norm, hit that. Okay, what area? We're talking about the 80th percentile, so that's 80.80. Our mean in this situation is 36.9. Our standard deviation is 13.9. Okay, and then we're looking to the left, and you just hit paste. Boom, there it is. So your value k such that the area to the left of k is 80% of the entire curve, all entire area underneath the curve is 48.6. Okay, so here